Just sit right back and you'll hear a tale of your faithful trip. It started in the firmament, and then we all got tricked. Life was great when we were young, with all the things we believed. Then it all got hard, unbearable, and we know we're being deceived. Forgotten, ignored, secret, and hidden. Topics that talk about how water is knowledge. Now drink from the fountain. Let's pour some on you now. Hello, everybody, and welcome back to Plain Mundane Show. What are cosmic rays? After the last video I uploaded, I started to look into some articles, and I was looking at gamma rays, and I was thinking about positronics and what else I could post about electromagnetic theory. And then it just dawned on me, I don't really know what cosmic rays are. I know what gamma rays are. I remember in science we studied alpha, beta, and gamma, and we put radioactive materials in a dish in our science class, and we covered it with the fog from dry ice. And you could actually see the particles shoot through the dry ice and leave a vapor trail, vacuum, not a vacuum, but a void. Where it was white, it would leave a clear streak, like a bullet hole in the CO2 cloud, and you could see it. But I never learned anything about cosmic or heard what cosmic is. So what is cosmic rays? Let's read this. This is by Elizabeth Howell, April 21st, 2016, from the Space website. I think, folks, as I read this to you, I'm reading it with a little bit of inquiry because I think I'm trying to discover a new conspiracy. Because if they're not defined and we use them in serious talk about space every day, and a lot of the terms you're going to hear, if you don't believe in space, or that we went to the moon, or that there's a solar system instead of a geosystem, then some of these terms might not sound right to you, and it might make sense to you for why this could be the formation or an actual conspiracy. So, and then we have to look at it and say why and what are they measuring? Okay, showers of high energy particles occur when energetic cosmic rays strike the top of the Earth's atmosphere. Most cosmic rays are atomic nuclei. Most are hydrogen nuclei, some are helium nuclei, and the rest heavier elements. What is helium? Hydrogen's 1, helium's 2. And the rest are heavier elements. What about all the ones in between? And what part of the nuclei? See, that phrase right there already caught me, where it doesn't say anything to me. Although many of the low energy cosmic rays come from our sun, the origins, how do they know? Many of them come, but they say they're not. You'll see later. Come from the sun. The origins of the highest energy cosmic rays remain as unknown and a topic of much research. This drawing illustrates air showers from very, very high cosmic rays. Air showers from very, very high cosmic rays. Okay, that's silly. Cosmic rays are atom fragments that rain down on the Earth from outside of the solar system. They blaze at the speed of light and have been blamed for electronics problems in satellites and other machinery. First discovered in 1912, many things about cosmic rays remain a mystery more than a century later. One prime example is exactly where they are coming from. Most scientists suspect their origins are related to supernovas, star explosions, but the challenge is that cosmic ray origins appear uniform when you look across the entire sky. The history: while cosmic rays were only discovered in the 1900s, scientists knew something mysterious was going on as early as the 1780s. That's when French physicist Charles Augustin de Coulomb, best known for having a unit of electrical charge named after him, observed an electrically charged sphere suddenly and mysteriously not being charged anymore. At the time, air was thought to be an insulator and not an electric conductor. With more work, however, scientists discovered that air can conduct electricity if its molecules are charged or ionized. This would most commonly happen when the molecules interact and intercharge with particles. I just had an epiphany. We're talking about, as they said at the top, particles from the nuclei, such as hydrogen and helium. Those are positive protons, okay? And to be conducted over air and to be used as an electric conductor, it was thought to be an insulator, not an electric conductor. But if you're in, again, here I go with my O word, the over unity. If you can create a generator that puts multiple times out of power than what you put in, that's an over unity system. If we could learn how to handle over unity systems, we would create positronic systems, and they could conduct over the air through ionization of charged fields. At least in my mind, it works. This would most commonly happen when the molecules interact with charged particles or X-rays. But see, right now the electrons are in the outer orbit, so you have to learn to, through induction, to draw that energy out of the nucleus of the atom, where the positron layer is within the atom. Wow, that makes sense. It comes to me just as I say it because I can picture it. With more work, however, scientists discovered that air can conduct electricity. I read that. But where these charged particles come from was a mystery. Even attempts to block the charge with large amounts of lead were coming up empty. On August 7, 1912, physicist Victor Hess flew a high-altitude balloon to 17,400 feet, 5,300 meters. He discovered 3 times more ionizing radiation there than on the ground, which meant the radiation had to be coming from outer space. Of course. But tracing cosmic ray origin stories took more than a century. In 2013, NASA's Fermi Gamma Ray Space Telescope released results from observing 2 supernova remnants in the Milky Way, IC 433 and W44. I used that to oil my hinges on my doors. Among the products of these star explosions are gamma ray photons, which, unlike cosmic rays, are not affected by magnetic fields. See, there you go. Magnetic fields, that's in your electronic generator. That's the negative side. That's the dirty side of the alternator. And unlike cosmic rays, they're not affected. I think cosmic rays are some form of positronics that we haven't defined yet because we don't know that much about positronics. I'm trying to answer the article before I read it to you. The gamma ray studied had some same energy signature as subatomic particles called neutral pions. Pions are produced when protons get stuck in a magnetic field inside the shock wave of the supernova and crash into each other. In other words, the matching energy signatures showed that protons can move at fast enough speeds within supernovas to create cosmic rays. Current science, we know today that galactic cosmic rays are atom fragments such as protons, positively charged particles, electrons, negatively charged particles, and atomic nuclei. While we know they can be created in supernovas, there may be other sources available for cosmic ray creation. It also isn't clear exactly how supernovas are able to make these cosmic rays so fast. Over unity. Cosmic rays constantly rain down on Earth, and while the high-energy primary rays collide with atoms in the Earth's upper atmosphere and rarely make it through to the ground, secondary particles are ejected from this collision and do reach us on the ground. But by the time these cosmic rays get to the Earth, it's impossible to trace where they came from. So how do they know they came from another solar system? It's impossible to trace where they came from. Do you see the conundrum here? Whenever we say the word conundrum, who are we talking about? That's because their path has been changed as they travel through multiple magnetic fields. And I'm not insulting the author at all of this article. Journalism is journalism, but where this information comes from and why it exists is the question. Okay, according to NASA, cosmic rays therefore come equally from all directions of the sky. Therefore, they must be from the solar system, right? So scientists are trying to trace back cosmic ray origins by looking at what the cosmic rays are made of. Scientists can figure this out by looking at the spectroscopic signature each nucleus gives off in radiation, and also by weighing the different isotopes or types of elements that hit cosmic ray detectors. The result, NASA adds, shows very common elements in the universe. Roughly 90% of cosmic ray nuclei are hydrogen protons, and 9% are helium alpha particles. Hydrogen and helium are the most abundant elements in the universe and the origin point for stars, galaxies, and other large structures. The remaining 1% are all elements, and it's from that 1% that scientists can best search for rare elements to make comparisons between different types of cosmic rays. Scientists can also date the cosmic rays by looking at radioactive nuclei that decrease over time. Measuring the half-life of each nuclei gives an estimate of how long the cosmic ray has been out there in space. The space radiation concerns. Earth's magnetic field and atmosphere shields the planet from 99.9% of the radiation from space. However, for people outside the protection of Earth's magnetic field, space radiation becomes a serious hazard. An instrument aboard the Curiosity Mars rover during its 253-day cruise to Mars revealed that the radiation dose received by an astronaut on the even shortest Earth-Mars round trip would be about 0.66 sievert. I don't know how much is a sievert. This amount is like receiving a whole body CT scan every 5 or 6 days. A dose of 1 sievert is associated with 5.5% increase in the risk of fatal cancers. That's an ugly measurement, unit of measure. The normal daily radiation dose received by the average person living on Earth is 10 microsieverts, or 0.00001 sievert. The moon has no atmosphere and a very weak magnetic field. Astronauts living there would have to provide their own protection, for example, by burying their habitat underground. The planet Mars has no global magnetic field. Particles from the sun have stripped away most of Mars' atmosphere, resulting in very poor protection against radiation at the surface. Humans in space. The highest air pressure on Mars is equal to that at an altitude of 22 miles or 35 kilometers above the Earth's surface, so it's quite a bit lighter. At low altitudes, Mars' atmosphere provides slightly better protection from space radiation. That's good to know. If some of our grandchildren decide to go there, we need to tell them this. So anyway, what have we learned about cosmic rays? What are they? Well, mainly it's impossible to tell where they're coming from. They've been there forever, and you can't tell what direction they're coming from, or why they're made up of parts of helium and alpha particles from helium and protons from hydrogen. More than that, we compare them to gamma ray photons, which you can measure, and I have done in the lab. So there's something to this. I'm going to start studying more about cosmic rays, and I might post some more articles and let you guys know. But otherwise, I hope you got something out of this, at least a launch to go. Somebody, please find out what cosmic rays are, and let's get to the bottom of this. All right, because we know a lot of the terms in this article don't exist. Like